Okay guys, today I'm going to show you just some examples of things we talked in class about how to do a truth table from something they want us to prove. How to prove something with a truth table. So the first thing I'm going to do is I've copied this, as you can see, this from here. Now what I'm going to do is I'm just going to draw my bars coming down, separating things out. Now, I've told you that what I tend to do is I mark down which one I do first, second, third, and I use a highlighter. When I use a highlight color, it helps me mark. So, I mean, I would advise you to do that. You don't have to do what I'm doing, but for me it's easier to do that. So I know I'm going to do my P and Q first, minding my P's and Q's, right? Okay, so now what I'm going to do is I'm just going to go generally on that. And since I know that this is going to be my P, that's my first one is always true, true, false, false. And Q is true, false, true, false. We talked about that being by convention. We all agreed to do this way so that we all come out with the same answers. It makes it easier for us to grade. So again, P is true, true, false, false. And Q is true, false, true, false. Okay. So the next thing we want to do is we're going to mark what our next step is. Well, so our next step is going to be, we have to follow order of operations, so we have to do what's in the parentheses first. So we have to do this second. So I'm going to do this second, which means this is going to be a conditional, which the conditional statement is false if and only if the antecedent is true and the consequent is false. So if I look, these two right here are both false to start with. So they must be true by that definition. Because the only time a conditional is false if the antecedent, P, is, in this case, is true and the consequent is false, which is Q in this case. So that's when this is going to be false. And here, the antecedent is true and the consequent is false. So this would be true. So then, again, to follow order of operations, if I look, these are like big parentheses. So I had to look within those parentheses to first do this. But now, the third thing I'm going to do, the next thing I'm going to do is the next one I'm going to do is that conjunction. A conjunction is true if and only if both P and Q are true. So I'm going to do this one now. Then that means I'm looking at this and the P to compare. So I first look and say I have true and true, so that's true. I have false and true, so that's false. I have true and false, so that's false. And I have true and false, that's false. So that was the third thing I did. Now we're trying to prove that this implies that all of this implies Q. And we've talked about in class is we treat that as a conditional. And if we come out with a tautology, which means all of them are true, if we come out with a tautology on this, then what we can say is it is a valid implication, because it's a tautology. So now what we're going to do is look at this, and if we look, we could say, well, it's, again, we're going to compare this and Q. and it's a conditional, which is by definition a statement that is false if and only if the antecedent is true and the consequent is false. So really at this point, the only thing I care about is this one here and this one here. Okay? So now if I look at that, then I'm going to say it's only false if and only if the antecedent is true and the consequent is false. So anytime the antecedent is false, it's the whole thing is going to be true. So this one is false, so that's going to be true. This one is false, that's going to be true. This one is false, so that's going to be true. And so the last part here is this is true, conditional, true. So that's true. And now what we're looking at is this a tautology? And when I look at this, I can see that is a tautology. So what we would write is this is a valid argument because it results in a tautology. Okay, so what this does is now we're asked to use a truth table to prove that P conditional Q conjunction Q conditional R implies P conditional R. Now we're going to have a name for this. Okay, this is a hypothetical syllogism, and we'll talk more about this in class. But right now we just want to see the truth table. We're going to use this strategy, so we want to prove and make sure this is a valid argument. Because if it is valid, we get to use it over and over again. We don't have to keep proving it. But today we're proving that through a truth table, this is a valid argument. That if we have P conditional Q and Q conditional R, that implies P conditional R. So if we said P means Scott gets good scores on his homework, Q represents Scott earned an A on the test, and R represents Scott has a good grade in logic, then what we'd be saying is if Scott gets good grades on his homework, then Scott earns an A on the test. And if Scott earns an A on the test, then Scott has a good grade in logic, which implies that if Scott gets good grades on his homework, then Scott will have a good grade in logic. Now, so it doesn't know, it's that we're asking, is that a valid argument? And we're trying to prove that that's a valid argument. And so if we looked, we set up our table. So as we magically put those lines in, again, we're going to mark which ones we do first, second, third, and fourth. We're going to go just, first of all, we know that we talked about when we have three variables, that when we have three statements, we're going to have 8 possible outcomes, because there's 2 outcomes with the P, there's 2 outcomes with the Q, and there's 2 outcomes with the R. And by fundamental counting principle, that means that our sample space has a total of 8. 2 times 2 times 2 is 8. So then we've drawn this out a few times in class. So we're going to have for P, it's going to be true, 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 false, 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 false. That's the first thing we're doing. And Q is going to be true, true, false, false, true, true, false, false. And R is going to be true, false, true, false, true, false, true, false. Now, one of the things you want to be careful of is that when you have 8 outcomes, I might tend to draw a line across here so that I can see that's my midpoint. Because when you start to line things up incorrectly, it makes it easier to make a mistake. So again, Q is going to be true, true, false, false, and we'll fill those in. P will be true, 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 false, 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 false. R will be true, false, true, false, true, false, true, false. And those are all the first things that I did. Those are given. We should be well practiced at that. Okay, so now what we're going to do is we have to look at, again, the order of operations. And so what we have to do first is we have to look and realize that we're talking about these right here being, this is parentheses, this is a big set of parentheses, and within those big parentheses are two little sets of parentheses. So we have to simplify those first. So again, I mark those as a highlighter in the ones that I'm doing first or doing second. So I've marked those with a highlighter just so I can keep track. But again, what I'm going to say is, now this is what I'm going to do second. So I'm going to do this second, and this second. So what I'm doing here is doing the conditional here, the conditional here, and the conditional here. So when I look at those conditionals, remember a conditional by definition, it is that the antecedent is the only time a conditional statement is false. It is false if and only if the antecedent is true and the consequent is false. And on all of these, the antecedent is false. Therefore, this got to be true. Now, then here, the antecedent is true. So that's going to be true, because the consequent is true. These two are the ones that the antecedent is true, but the consequent is false. So these are going to be false. So we move to this column now. Now we look again. Again, it's a conditional. By definition of the conditional, it is false if and only if the antecedent is false, is true, and the consequent is false. So again, we look and we can automatically with any, it's going to be false as the antecedent, therefore it's true. Anytime the antecedent is true. And when the antecedent is true, then if the only time it's false is if the consequent is false. So here's our false, true, and true. Okay, so now we're going to go over to the third one, and we're going to do that one. And again, the only time a conditional statement is false if and only if the antecedent is true and the consequent is false. So again, we look here, this is true, false, true, false, true, 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 true. Okay, so at this point, this is where some of this gets to where you have so many true falses up here. It can get a little confusing. So what I've shown you in the past is to be able to put a few things, to put little tabs up there. So if I cover the ones I don't need anymore, because we've done those, as long as I haven't made any mistakes here, then when I look at this, this is now what I'm going to be comparing. So as I'm comparing the rest of this, now I need to look at, I'm going to do this conjunction. I'm going to look at this conjunction here, and that's going to be the next thing I do. So now if I look, that's a conjunction. A conjunction by definition is a statement that is true if and only if both P and Q are true. So then if I look at this, it's true and true, so this is true. True and false, so that's false. False and true, which is false. False and true, which is false. Here I have true and true, which is true, and true and false, which is false, true and true, which is true, and true and true, which is true. So now I've compared these two. That was my third step. Now for the fourth and final step, I have to test the implication. And when I test the implication, I'm going to be using it as a conditional. And so I'm going to go ahead and move another bar over here to cover this, because I've used these and they're not what I'm comparing anymore. What I'm now comparing is going to be this one and this one. And it's going to go right here. And again, it's a conditional. So by definition of a conditional is false if and only if the antecedent, which would be here, is false, is true, and the consequent is false. So when I compare here, true and then true, that's true. False then false is true. False then true is true. False then false is true. True then true is true. False then true is true. True then true is true. True then true is true. And that gives me a tautology. So I write that the answer is this is a valid implication. Because of the tautology. So what we've just proven is that we have a statement that says that basically if Scott gets good grades on his homework, then Scott earns an A on the test. And if Scott earns an A on the test, then Scott will have a good grade in logic, which implies that if Scott gets good scores on his homework, then Scott will have a good grade in logic. We've just proven that that's a valid implication. The name we're going to have for this is called a hypothetical syllogism. I hope this was helpful. Please let me know anything that on this that might be valuable for me to improve upon. This is the first video I've done. I'm looking forward to it being successful for you, a valuable tool for you. The whole purpose is that it might help you to be able to take notes, to be able to better understand, and to have it slowed down, because you can pause this anytime you want. Okay, have a good day. Enjoy logic.